Good morning, everyone. Today for lesson 4, we'll be doing the kinetic molecular theory and phase changes. I'm going to try this out real quick. People see me. So this is our 4th day on matter and the different phase changes that matter goes through. You'll know a lot of the words already for today because we use them in common language, and a couple will be new. Back in. So, notes, learning target. I can identify the 8 phase changes that occur between the 4 states of matter. I can apply the kinetic molecular theory to phase changes. Kinetic molecular theory, just a scary word for something that's actually really, really simple. If you already watched that video posted in the plan, you already know it. Kinetic energy is the energy of motion and molecules, so it's how the motion of molecules affects the state of matter that it's in. It's really that simple. 4 states of matter that we'll be looking at the changes between. We have solids, liquids, gases, and plasma. Not all states of matter not all types of matter can be in all 4 states. It really depends on the compound itself. Elements can be in all 4 states, but if it's a larger molecule, meaning chemical bonds exist between atoms, depending on how much energy goes into the molecules, they might break down before going through a phase change. Let's dive in. First one, so from solid to liquid. So we're moving along this arrow from solid to liquid. Your ice cube tray sits out on the counter and it goes through what? It goes through melting. Right? It will melt from a solid to a liquid. Let's keep going up. If you were to increase the temperature, right, as you're going up this line, as temperature increases, that liquid water you put in a pan and you put it on the stove. That liquid water will turn to a gas as it boils. Boils or boiling. You can also use the more scientific word here called vaporization. But don't use the word evaporation. Evaporation is a special condition where you get a liquid to gas transition at below a boiling point. Vaporization is actually the kind of best word for it, but I'm fine with the one you would more commonly know, which is boiling, because we do that all the time when we're cooking. Let's go back down this line. So as temperature decreases, gas to liquid, that would be, if you think about on a window in the winter, you'd say all the droplets of water on the window that form, especially by the time you wake up in the morning on really cold days as the heat is blowing on it, say there's condensation on the window. Or you can draw on the window of your car using the condensation, and you draw through that. So gas to liquid is condensation or condensing. Keep going down in temperature from liquid to solid. You take the liquid, you put it in an ice cube tray, you put that into the part of your refrigerator that is really, really cold. It's called a freezer because the phase change here is freezing, going from liquid to solid. Ones you don't know as well. So gas to plasma, notice you can actually only get to plasma from gas. If you go from gas to plasma, that would be ionization. Thankfully, they named the plasma to gas very nicely with this. It's deionization. You are reversing the ionization. So deionization. Last two, you might if anyone has been skiing out in the Mountain West, you may have actually seen this happen. A solid going directly to a gas without going to liquid first. We'll see this on some nice, warm, low-pressure days in the mountains where it will snow. And that snow pile will actually completely go to gas. It'll look like it just disappears without forming a puddle via the process called sublimation. Pretty nifty. And the reverse, gas back down to solid. Not as well named as our ionization, deionization up here. We do need a new word. This is called deposition. You typically see sublimation and deposition out in the Mountain West due to the lower pressures that we have at higher altitudes. But we do see deposition here, gas to solid. If your parents send you out to clear the windshield on a cold winter day, all that frost that forms, that really thin layer of crystals, that's deposition. Feel free to watch some videos for this. Type into YouTube, sublimation. There's some awesome videos of sublimation. Do the same for deposition. You'll get some cool ones for that. There's a really cool one for instantaneous freezing by Veritasium, where they super cool liquid, and then with a slam on the counter, the entire liquid water immediately freezes. You can watch the crystal growing through it. Type in ionization. You'll see some cool stuff too, like the plasma globes, or type in plasma globes. Last thing I want to do in this quick lesson, we already looked at temperature. So as temperature went up, you went from solid to liquid to gas to plasma. Or with the right pressure combination, you can go straight from solid to gas. If temperature goes down, you'd see the reverse behavior. Let's look at kinetic energy, so the motion of the molecules. We said the kinetic molecular theory is how the motion of the molecules affects the state of matter. The kinetic energy generally is going to be increasing as we move through these states of matter. So I'm going to make the same direction arrow as our temperature there. The kinetic energy will increase when you go from solid to liquid to gas to plasma, or from solid to gas to plasma. Last, how about closeness of the molecules? Well, actually, that'll be inverse. So the molecules are closer together when they are down as liquids and solids. So I'm going to reverse that arrow. They actually spread out. So as the kinetic energy increases, they become less close together. They spread out further apart. Both of these videos that are linked here in this document that you have are also posted to the plan. Feel free to check out any fun videos of phase changes. And then go ahead and do your homework. I want to do this as a preview into the next section on heating curves. Google the term heating curve, then paraphrase, meaning your own words. You are not copying down word for word what someone else says. You're taking a few sentences from them, maybe a paragraph from them, and condensing that into 2 to 4 sentences of your own wording. Cite the website you used. Figure out how to cite. I don't care if you use MLA, APA, Chicago, but I want you to try citing them. And then based on what you said here, figure out which of these models. Model number 1, where you have a linear increase in heat, or linear increase in temperature as heat is applied, solid, liquid, gas. Or do you have model number 2, where you see a linear increase of temperature as heat is applied, and then a plateau, where temperature does not change, then a linear increase as heat is applied to a liquid, and then a plateau, and then a linear increase in temperature as heat is applied to a gas? Which model is correct or incorrect? I think I actually say explain what is wrong with the model that is incorrect. Good luck with learning this. I will